This is the 2023 Maths Paper 1 Calculus question. We're on question 7, part A. It says Fiona is driving on a motorway and she passes a point A on the motorway. Her speed, important it says speed, doesn't say distance, her speed is given by, and that's V. So V stands for velocity, which for us in higher level maths just means speed, same idea. Applied maths a little bit different. 2 over 3 t cubed, so it's a cubic, that's grand, maybe. Our cubic stuff will come into play, maybe not. Minus 6t squared, plus 13t plus 109. Okay, cool. So that's the thing we're going to be dealing with. It said V is our speed in kilometers per hour, t is minutes after passing the point A. It says it works for the first 5 seconds. 0 is less than or equal to t, less than or equal to 5. Work out Fiona's speed when she passes the point A. So just work out her speed when she passes the point A. So it's asking for her speed at 0. That's all it means here. It's just saying put this lowercase t equals to 0, because that's the beginning of the experiment. Some people would write it like this, that's completely fine, but essentially no matter which way you write it, you've got 2 over 3 times 0 cubed minus 6 times 0 squared plus 13 times 0 plus 109. And then when you work that out, that is just going to everything. 0 is going to cancel on absolutely everything. You're just going to be left with 109. Now don't forget your unit. They told you in the question that's kilometers per hour, so make sure you put that in. And for 5 marks overall, how did we get how is that actually given to us? So 5 marks for this to begin with, but there was a low partial credit of some sort of correct substitution. Even something like that was fine. That got you 2 marks there by itself. Or if you substituted in that t equal to 5, if you put t equal to 5 into there, they actually allowed you to get the low partial credit with that. You did lose 1 mark if you didn't do the unit. If you didn't give them the unit, you would have been down to 4. Not all the way back to 2, but down to 4. An easy start to this question. This is the 2023 Maths Paper 1. It's a calculus question, question 7, but we're on part B, which says work out Fiona's acceleration. That is the rate at which her speed is increasing 5 minutes after she passes the point A, and give your answer in kilometers per hour per minute. Okay, so not too bad here. They've given us this function originally here, which was speed, and if we differentiate that, that's going to give me the acceleration. Same way if we did distance, that would get you speed, and then again acceleration. So first thing I want to do is I want to integrate this. So v dash t, or dv dt if you want. Bring the power down in front and drop the power by 1. The great thing is that when you bring the power down in front here, the 3's cancel, so you get 2t squared. Bring the power down in front, drop the power by 1. Bring the power down in front, drop the power by 1. That number disappears off the face of the earth. That's gone when we differentiate. So that's a function for the speed now. But they said do it after 5 seconds. So if we now sub in t equals to 5, we've got 2 times 5 squared minus 12 times 5 plus 13. And we stick that into the calculator. That gives us 3. Cool. And don't forget your unit, which they literally told you was kilometers per hour per minute. So there we go. You could write it slightly differently for the unit there, but make sure you do write it all the same. That gives you 10 marks. They actually accepted it without the unit in this one, which is weird because they didn't accept it in the last question. But for going forward, they might not accept it. So please write in the unit. 10 marks overall. How is it broken down? Any sort of correct differentiation, even if it wasn't fully correct, got you 4 marks, any sort of correct one. If you substituted into the correct derivative and then subsequently somehow got it wrong, you got 7 marks. Or if you had 1 error in differentiation but then finished it off correctly, that also got you 7 marks, but 10 marks overall. This is the 2023 Maths Paper 1, question 7. It's a calculus question. We're on part C, which is led in from part A and part B. They've given us this function earlier on in the question for this girl Fiona's speed, or her velocity here. But it says, find the time, the value of t, at which Fiona reaches her maximum speed. And I'd underline the word maximum there, because maximum we know means we're going to be using some sort of differentiation, which we did do in the previous part of the question, but we'll do here again. During the first 4 minutes after she passes the point A, give your answer correct to 2 decimal places. When it says maximum, we need to know, we have to know that what we're going to do is we're always going to get the first derivative, we're going to put it equal to 0, solve for x, and then sub back into the original to get y. Brilliant. So that's kind of what we're going to be looking at doing here. So find the time you get her maximum speed. If we get the first derivative, what we're going to do is and we would have had this from the last part of the question, just so you know, bring that down in front, drop the power by 1, bring that down in front, drop the power by 1, bring that down in front, and that disappears off the face of the earth. If we now put that's a function for her speed, but if we put that equal to 0, for acceleration, if we put that equal to 0 and now solve, that's the same idea as up here. So instead of x, we've got t here, and that will be completely fine. You can solve for that using factorizing if you're able to, but I don't think you'll probably be able to do that. I would suggest that we would be using this minus b formula here. So the minus b formula, probably you know it off by heart, but it comes into place for any quadratic where we're having any sort of difficulty. I tend to use it if there's a number in front, or it says give your answer correct to decimal places, like it does here. So minus b plus or minus the square root of b squared minus 4ac all over 2a. I always write down what a, b, and c are. A is the coefficient of the squared, b is the coefficient of it's usually x squared and the x, but in this case just the t, and c is whatever is left over. And sometimes there might be more than one thing left over in a different style of question. We've got 2, minus 12, and 13. If we fill it out, minus, and I like to use brackets, minus b plus or minus the square root of minus 12 squared minus 4 times 2 times c all over 2 times 2. Stick that into your calculator once with a plus and once with a minus. You get t equals to 4.58 and you get the t equals to 1.42. Now, it's very important that it says her maximum speed during the first 4 minutes. So therefore, this is our answer. It's where t is equal to 1.42. There are other ways of doing that if you wanted to. But yeah, that's absolutely fantastic there for part C. How are the marks actually broken down on this here? Well, you've got 10 marks going overall. So it takes your derivative from the part before. If you in part C you got the derivative wrong and you got downgraded for that there, you would not be downgraded again here. But I've just done the differentiation for us here. And if your derivative was linear, you got most low partial credits, which was 4. So that's very important. If you got the first derivative and put it equal to 0, or even showed that got you 4 marks. If you substituted into the formula or you evaluated for t, after that would be your other 2 steps. If you did one more of those, that got you, say, 7 marks. If you did this here, you got a full marks for getting this correct and identifying it here, but you did lose a mark if you did not specifically exclude that, or if you were rounded incorrectly, or you didn't round it but it was otherwise correct. So that would have given you -1 if you didn't, to say that this was the answer and this wasn't. But overall, 10 marks. Handy enough when it said maximum speed. We just went into default mode of using maximum in calculus. This is the 2023 Maths Paper 1 Calculus question. It's question 7, part D. We've already done some things on this function here, which is a function for Fiona's speed. Part D says use integration to work out Fiona's average speed. It literally says use integration. The fact that it said average should also indicate integration. Over the first 5 minutes after she passes the point A, give your answer correct to 2 decimal places. So, first of all, there's different ways of getting the average idea at the end. I'll point that out at the end, but I'm going to integrate this. And maybe some people would have something different a little bit at the start, but I'll allude to that once we finish the question. I'm going to integrate this idea here, this function between 5 and 0. That's kind of going to give me almost like the total speed. If I add all the speeds together there, that's what it's going to give me. So we're going to do that. dt just means please, because we're doing it with respect to t. It doesn't mean anything to do with the integration unless you do applied maths. So we're good with that here. When we integrate here, it's very important we don't get that mixed up with differentiation. As we go from left to right here, there's nothing crazy, no chain rules or product rules. All we do is raise the power by 1 and we divide by the new power. So if you think about it, 2t cubed over 3, I now have 2t to the power of 4 to the power of 4. That tidies up into t to the power of 4 over 6. Just be very careful with that here. That's a bit of a weird one. You can rewrite that as this here, which would be 2t to the power of 4 over 3 by 4. But you could see that that would be 12. That would cancel. You'd get this here. A little bit easier as we go across here. We've got raise the power by 1. Raise the power by 1. Divide by the new power, which you could definitely cancel if you wanted to. But there's no real point at this stage to do it, except for that first mess. Raise the power by 1. Divide by the new power. Raise the power by 1, which just means add t. You could divide by 1 there if you wanted to. Now remember, what we're going to do is we're going to now integrate that between 5 and 0. So if we do that between 5 and 0, what you must do is sub in 5 wherever you have t. Okay, so we would have 5 to the power of 4 over 6 minus 6 to the power of 5 cubed over 3 minus 13 to the power of 5 squared over 2 plus 109 to the power of 5. Now, hard for me to fit that in on the board, but that's going to be one thing. And then that answer gets subtracted by what happens when you put 0 in. So you've got 0 to the power of 4 over 6 minus 6 to the power of 0 cubed over 3 minus 13 to the power of 0 squared over 2 plus 109 to the power of 0 there. Cool. So if you subtract them from each other, you get like a really, really big answer. And that's obviously not her average her average speed. Because like I think when it comes out, you get something like 570 kilometers per hour. That's not her average speed. So this is where I said I would come into the average part at the end. That would be the total. If they asked you for her total speed, it would be add all the speeds together, which is a bit random. You would see a lot of teachers, a lot of marking schemes would have 1 over b minus a on the outside when it says average. This being b, this being a. Absolutely no problem. So the whole way across, if you had 1 over 5 times 5 minus 0, that would be okay. And maybe you would see it the whole way up here and bigger brackets with that as well. Maybe you'd see it over here, simplifying to 1 over 5. That's okay. But what I would suggest you do is actually get your total answer, and when you get it, just divide by 5. Divide by the difference between those two numbers. Makes absolutely no difference which way you do it. In any case, it says give your answer correct to 2 decimal places. Whatever you do with that 5, you get 112.33 kilometers per hour. And that's the answer to the question. How many marks are going for that? Well, 10 marks overall. If you did any work of merit, like for example some sort of integration, even though they told you to integrate, you still got 3 marks. If you if you actually integrated correctly, you got 5 marks. So where did we have that? Up here, so 5 marks. If you subbed in your limits, which are these ideas here, if you sub those limits in, you would have got 8 marks, and then 10 marks overall for this here. Now note, they did take a mark off you for not rounding correctly. They definitely did that. Or if you didn't put down a unit, or you put the incorrect unit down, you also would lost a mark down to 9. But overall 10 marks, and considering they said integration and average, it should be an absolute banker for any student that knows a little bit about integration. This is the 2023 Maths Paper 1, question 7. It's a calculus question. We're on part E, where it starts to get a bit functionally, kind of a few diagrams here, but we have to understand calculus with it. I haven't drawn the diagrams on the board. You have them there as best as possible, like in front of you. If I drew them, it might mess things up even a little bit. But let's look at the question. It says, taking v dash x to be the derivative of v and v dash dash t to be the derivative of v. And it says the first derivative is greater than 0. The second derivative, when you put 1 into both of them, is less than 0. And that's fine. It says 4 graphs A, B, C, and D are shown below. It says close to where t equals to 1, the graph of this must look like one of the 4 graphs above. So where t is equal to 1, the graph must look like this. Write down which graph this is. Justify your answer using both the first derivative and the second derivative when you sub 1 in. So we had v, we've dealt with v for the previous 4 questions. It was a cubic. And they're saying here, which one of these curves must it look like at the number 1? Now, there's different ways that you could start to work through this, maybe drawing them out, etc. This didn't go very well for them. There's only 5 marks going for this entire piece here. The answer is graph B, right? So the answer is graph B here. So how do you know that? Well, you know when you get a first derivative, you're talking about the slope. It's a function for the slope. No matter what you're talking about, it's a function for the slope. And then from the second derivative, what you can then tell is when you put a number in, if it's less than 0, we're talking about going to like a maximum or a minimum if we were doing max minimum points. So that tells you a little bit about what's going on with the slope itself. Well, so if you say B, right, so if we say B, if we just look at graph B there, how do we know it's B? Well, we know that because when you get the first derivative, which by the way we've already gotten, and so you could use the numbers there, but they've told you this, when you get the first derivative and it's greater than 0, that means that the function is increasing. So the slope of that must be positive. If you get the first derivative, that's a function for the slope. If you put a number in, if you get a positive number, well then that's an uphill slope, which means it's positive. If it was a negative number, it would be a downhill slope, which would mean it was negative. The second derivative, so this just means that the slope is positive. Cool. And the second one here, they've told us that this is greater than 0. So how can we use that to justify? Well, because that is less than 0, the rate of the increase of the slope is actually slowing down. And that's what we said before we could use with maximum or minimum points. But if we use the second derivative here and we put in a number, if the second derivative is less than 0, if you think about it, the slope is telling you what's happening in the function. This is like a slope of the slope. So this is telling you what's happening this slope. So the fact that this is less than 0, the rate of the increase of that slope is slowing down. And that's the kind of mathematical way. Or they also said you could just say that the slope overall of the function is decreasing. So I don't mean the first derivative or second derivative, I mean the slope overall is decreasing. Now 5 marks went for this here. You need a justification with both of these, or you can have this single combined sentence there, that's no worries. Substitution into those things from before is not considered a work of merit, the thing we used before, but it might help you work it out, so might be an idea. 3 elements, you got to say B, and you got to talk about these ideas here. If you got just the answer correct, which say is B, you could get 2 marks. If you got one of the justifications, let's say that will give you 3, and then overall 5 marks for this question. Maybe not looking at this question in great detail again, but understanding what the first derivative means about a function and what the second derivative means about the slope of that function. Is the 2023 Maths Paper 1 Calculus question. It's question 7, part F. It says there is an average speed zone on the motorway starting at point A and ending at point B. The distance from A to B along the motorway is 10 kilometres. Cameras record the time taken for each car to travel from the point A to point B. Each car's average speed from A to B is then calculated. Part F says work out the minimum time in minutes that a driver could get from A to B while not driving above 100 kilometres per hour. When we're talking about speed, in my head I'm thinking some sort of calculus potentially, or something from primary school, which is the DST triangle. So you might recall this distance, speed, time. Now, because here they were talking about this average speed zone, we can use this idea. This only works if we're talking about straight lines here. So if I'm trying to find out the minimum time, I'm trying to find time, I can cover t, and I know that that's distance over speed. So time is equal to distance over speed. In this question here, the distance they've told me is 10. The speed, we want it to be 100 because that's what they asked for it to be. And that equals to 6. Don't forget the unit there of minutes. That was 5 marks overall. Dips you into kind of the second part of the question. They gave you the reason I put that in a bracket is they gave you full marks of 5 without using the units. However, you see even in this exact question, sometimes they took money off you from beforehand. So I'd always put the units in no matter what. Partial credit will be some work of merit. Full credit will be if you said it was 1/10. Like, you're not going to say, oh yeah, how long did it take you to get into town? Oh, it took me 1/10. So that's why they would actually take 1 mark off you. But 5 marks overall, 2 marks for partial credits, any work of merit, should be an easy 5 marks for people. This is the 2023 Maths Paper 1, question 7. It's a calculus question. We're on part G. where it's actually turned into a little bit of a puzzle, more so than calculus here, to be honest with you. And we got to set it up as such. We got to think to ourselves that there are partial credits on display here. It's not going to click straight away what sort of question this is, like potentially the rest of the question. Its poor performance by students is reflected in the fact that it's only worth 5 marks. Your real job is to just try to secure as many of these as possible. I'm not saying it jumps straight to mind in this question. It says Rowan drives from A to B. So if you don't know what we mean by A to B, just read the previous part of the question. He passes the point A, driving at a constant speed of 120 kilometers per hour. After 2 minutes driving at this speed, he starts to decelerate, reduces speed at a constant rate until he reaches the point B. Overall, his average speed in driving from A to B is 100 kilometers per hour. Work out his deceleration. Give your answer kilometers per hour per minute. So we're trying to find out his deceleration. Now, if we just put this on a timeline here about what's going on, we've got A here, we've got B here. This is more so for me in the question to help me explain to what's going on. But you should probably put something like this down as well. Well, what do we know overall? Well, we know overall from earlier on in the question, by the way, from before part F, that the distance between these two spots is 10 kilometers. So not 10 kilometers per hour or anything. This whole entire distance is 10 kilometers. They told us that earlier on in the question. But what do we know here? He passes A driving at 120 kilometers per hour, and after 2 minutes driving, he starts to decelerate. So I don't know where it is. I'm just going to put a random notch in here. That's where he starts his deceleration. We'll put that there. But we can actually take a couple of things from this. First of all, it's after 2 minutes. So this part of the journey here is 2 minutes there, and that's no problem whatsoever. How do we find out how far he's travelled? Well, knowing that he was going at 120 kilometres per hour, and if you say 120 kilometres multiplied by 2 over 60, that actually gives you 4 kilometres. So not only is that 2 minutes, but that's 4 kilometres, which means that this part here must mean he's got 6 kilometres remaining to get to B. So when he started to decelerate, he's now got 6 kilometres remaining. We want overall for his speed to be 100. That's what it says in the question. His average speed to be 100. So that would be the 10 kilometers it takes over the total time, which we're not 100% sure what we're talking about here. We want that to equal to 100. And if we flip these around a little bit here, the total time must be, 10 over 100, which is 1/10 hours. Okay, so we must have 1/10 hours there, and 1/10 of an hour, that sounds a bit weird, which is 6 minutes. So what we now know is this entire thing here must be 6 minutes. So this part here must be 4. So that part there must be 4 minutes. Now, if we're looking for the average speed on that, 4 minutes of an entire hour is 1/15. So 4 minutes of an entire hour is 1/15. If we take this 6 kilometers and we divide by 1 over 15, so like the 1/15th, that's what the 4 minutes is, you get 90 kilometers per hour. Okay, so we know here that he's gone down to 90 kilometers per hour, and that's fantastic. Which means that when he's slowing down, his average speed overall, is the 120 plus this final speed. So plus this final speed over 2. So we've got 120 plus this kind of final speed here. So the speed when he gets to B, because remember he's decelerating the whole way through this, over 2, and we know that equals to 90. That's where we've come from in this. We have found that 90 is his average speed throughout the entire trip. We know we've got 120 here, and we know that it's getting decelerating, it's getting lower and lower from 120 to here, but we've found his entire speed overall is 90. How did we do that? There was 6 kilometers that he was travelling we got the total time, so this is his average speed. Not to say that it's that speed the whole way across. So we know the original speed plus this end speed here over 2 equals to 90. Because if you think about 90 being the average, we've got the maximum, we've got the minimum one down here. That gives you that V, if you bring this up as 180, bring the 120 across, V is equal to 60. So his final speed here at this part is 60 kilometers per hour. But that's not what they asked you for. They asked you for the deceleration. So the deceleration comes from him going 120 kilometers up here down to 60, okay, but also 120 kilometers here. Remember, they said this part of the graph is 120, and he only actually decelerates from here. So what we are able to say from that is that it goes from 120 down to 60 in 4 minutes. So it basically goes down 60 in 4 minutes. So if we take 60 and divide by 4, that means 15 kilometers per hour per minute is his deceleration. Or if you said minus 15, that's fine because it's deceleration in that question there. Not an easy one at all, but we do have 5 marks going for it. If you said the minus, that's good because it was the deceleration part there, that would be fine. Some correct substitution into relation to distance here is 2 marks. The mid partial credit would be that you identified that this was 4, and then that we had 6 left over here, so that's 3 marks. Not too hard to do. High partial credit would be you calculating this 60 here. There's a few ways to do that. If you want to look at the marking scheme, maybe you might find a slightly different way. Full marks will be getting this. You did lose 1 mark if you said kilometers per hour, because it did say hour per minute in the question. Overall, tough question, well worth going through and drawing this out for yourself again. See, can you piece it apart, the different stages. Constantly 120, then the deceleration. If you can get the distance, brilliant. If you can get the time, brilliant. That allows you to piece it together. I would suggest that if you can get your head around what this 90 is, it's the average for the whole trip. It will make life a little bit easier.